Hi, this video looks at the solutions to the Year 11 Extension 1 Assessment Task 1 for 2023. Here are the answers to the multiple choice section, and I'm going to then work through question 6 and have a look at how we allocated marks and generally how everybody went with those questions. Okay, so here's question 6, part A. The question said to find the polynomial q of x that satisfies x cubed plus 2x squared minus 3x minus 7 in a way that it is factorized into x minus 2 times q of x plus a remainder of 3. And the question was worth 2 marks. Overall, this was done really well. It's not a difficult question, so if you were to use your long division and get the correct answer and show working, you would have got your 2 marks. If you made one mistake working through that, you would have got 1 mark. If you made more than one mistake, you would have missed out on that mark. There was 2 methods that people used in doing the long division. Some people just straight off divided this polynomial on the left-hand side by x minus 2, showed that they had a remainder of 3, and that was the quotient that they ended up getting as a solution. There was a few people that went and took 3 from both sides and then got therefore a different left-hand side and then showed that they had 0 remainder on the right. Both were okay. I'm going to leave the remainder of 3 and show that we get a remainder. Okay, so using your long division, you're just going to see how many times does x go into x cubed, and you're going to find that you need an x squared. X squared times x gives us x cubed. X squared times minus 2 gives us minus 2x squared. You're always subtracting the bottom polynomial from the top one. So I'll end up with x cubed minus x cubed, which is 0, and I'll end up with 2x squared minus 2x squared. So 2x squared plus 2x squared, which is 4x squared. The 3x and the 7x are coming down because we're not taking anything from them. You would have then said, okay, I now need a 4x to multiply through. 4x times x gives me 4x squared. 4x times minus 2 gives me minus 8x. And I'm going to subtract those 2 polynomials again. So the 4x squareds give us a 0. I'm going to end up with minus 3 minus 8, which is minus 3 plus 8. Now that's the only mistake that people sometimes make on those, is that knowing that we need to look at minus, and if there's a minus, we get a plus. So minus 3x plus 8x is going to give me positive 5x. The minus 7 comes down. My next value at the top needs to be a plus 5, and then I'm going to end up with 5x, take away 10, and then I'm going to subtract those again. The 5x's disappear, which is what I want, and I'm going to have a minus 7 minus 10, so a double negative again, which is going to give me my remainder of 3. So in dividing there, I'm getting that remainder of 3 down the bottom here, which matches my remainder there. So I know I'm happy. I've divided by the x minus 2. And so my quotient is the value that I have up the top here. So you needed to state what that quotient was and write that down. And that would have given you your 2 marks for that question. Part B says to consider the polynomial p of x. And we've got p of x here. And there's an unknown value of k in there. And to consider a of x, which is x minus 3. Part 1 says that given that p of x is divisible by a of x, show that k is equal to 6. And this was only 1 mark. It was fairly straightforward. Most people did okay with this one, and there was again 2 methods that people used. The one I would have preferred for you to do is to find out what p of 3 is, because we know that if our polynomial p of x is divisible by a of x, if I sub in 3 into my polynomial, then that's going to be equal to 0. So in doing that, we will end up with a value for k. That's what I would have preferred you to do. But because it was only 1 mark, there was a couple of people that decided to put the 6 in here and then show that when I divided the 3 through the polynomial that I got 0 as a remainder. But I would prefer the other method, but I marked both correct because it was only a 1 mark question in this case. So p of 3, pop that into your polynomial. And when you substitute your value of 3 into this polynomial up here, you're going to end up with 3 cubed minus k lots of 3 squared plus 5 times 3 plus 12. And that's going to be equal to 0 because we know that it's divisible. Therefore, we don't have any remainder. Expanding that out, I get this next line. Grouping like terms, I get this next line. Rearranging, I get 54 is equal to 9k, and therefore k is equal to 6. for your 1 mark is what you needed to do. The second part says find all the zeros of P of X when K is equal to 6. And that was worth 2 marks. And again, overall, most people got this question out, which was really good. Okay, so you first of all needed to rewrite your polynomial P of X. Where there was a K, they're saying, well, K is equal to 6. So we don't want a K in there anymore. We want a 6 in there. So that's our first step. And we already know, and they've given us that X minus 3 is divisible by that polynomial. So I would, in this case, use long division would be the easiest method to find your other factors. Other people, I think there was a couple of people in here that looked at the factors of 12, which you could do as well. In this case, because there are a lot of factors, positive and negative of 12, that would probably be the longer method to do this. So in this case, we want to use long division. Okay, using long division, I know I need x squared at the top there. X squared times x gives me x cubed, and times 3 is minus 3x squared. Like before, we're going to take them away. The x cubes are going to cancel out. I'm going to have minus 6 minus 3x squared, which is minus 6 plus 3x squared, but I'm only going to have a minus 3x left there. And the 5x and the 12 are going to move down because I'm not taking anything from them. Now, I need to figure out what I need to times x by to get minus 3x squared, and that's going to be minus 3x. So I'll end up down here with minus 3x squared plus 9x, and I'm going to take those away again. I'm going to get a 0 there. You don't need to put the 0 down there if you don't want. And I'm going to have 5 take away 9x, which is minus 4x plus 12. One more step. I need to figure out what I need to times x by to get minus 4x, and that's going to be minus 4. So we'll end up here with minus 4x plus 12. And I take those away. I'm not going to fit that in there. I'm going to end up with 0. So what I can see there is that this value of x minus 3 we know divided into our polynomial, but our quotient here has given us this 0 remainder, so that's perfectly divisible as well. So we can now write our polynomial P of x as x minus 3, x squared minus 3x minus 4. Now, that would not have given you full marks because what the question said is find all the zeros. I don't have the zeros there yet. You haven't shown me the zeros and haven't shown me that you know what the zeros are. So you need to factorize that polynomial one step further, and you need to get that quadratic factorized as well. So when I factorize my quadratic there, I'm going to end up with x minus 4 and an x plus 1. Now, to find our zeros, we'll let that P of x be equal to 0, and I'm going to end up with my zeros being 3, 4, and minus 1. If you did not give me those written down as the zeros and you just left it like that, you would not have gotten your full marks in this case, so you needed to go the whole way for those 2 marks. Okay, part C was this question, and it said that a team of 5 is to be chosen from 4 boys and 5 girls. How many teams are possible if 2 girls must be included? And that was worth 2 marks. Now, the wording on this in the end ended up being a little bit ambiguous, so I actually accepted 2 answers for this one. Where it says 2 girls must be included, well, either they already are included or they're not included, but they need to be included. So because the wording was a little bit iffy in that case, for that, I've selected 2 solutions and I've checked with other teachers of that, and then, yeah, they agree with me on that. So let's have a look at the working for the first one. So the first thing I looked at is if the 2 girls that are included, also should say 2 girls included, if they're already included, and they've been put in already, then we're only choosing from 4 boys and 3 girls because we're thinking of those 5 girls having had 2 removed. So, in this method, if those 2 girls are already in, then with the team of 5, the team only needs 3 more. Oops, I'll just fix that up. So we've already got 2 in there. So what we'd be picking in that case would be, we'd be picking, or in better wording, we'd be choosing those 3 here that we need because there's 5 needed. We've already popped 2 in, and we've got 4 plus 3, which is 7. And that would give us 35 combinations to pick from. Well, how many teams are possible? That would be 35. Because again, we're sort of unsure about the wording of this one, the option 2 I accepted was that there needs to be 2 girls included, but they have not been included yet, so we still need to include them. And in doing so, we've chosen 2 girls from the 5, and that will give us 10 options in which that can happen. And we're going to multiply that by the rest of the team, which would be 3. And we're going to choose 3 from 7, because if we've chosen 2 girls already, this is similar to the first part, there's 3 left, so 4 plus 3 is 7, and that's the 35. So that will give us 350 different ways. So I, in this case, was accepting either one of those. Some people did at least or at most. No, they're not options. That was not what we were wanting. So that would have given you 2 marks if you showed me working on how you achieved that result. Okay, and here's the last part of question 6, which was about the 4 married couples in a room. Now, this overall was not done very well. I would have expected that you should have got this question out because it was a question-aided task. And if you had have gone home and worked through that task and studied that quite well, you should have known how to do this. So I think that if you did not get this question out properly, it would have been because you did not do enough preparation for your solutions for this one. But we'll work through it anyway, even though it was on the question-aided task. So it says 4 married couples are in a room. Part 1. In how many ways can 4 people be chosen if, and our first one says for 1 mark, the 4 people chosen represent 2 married couples. Check this out. I like to think of it as a diagram. Here's our 4 married couples that we were given at the start. So there's 4 married couples in a room. Here they are. Our 4 couples, 1, 2, 3, and 4. I've just stood them together. So there's 8 people. But part 1, in looking at the 4 people chosen, represent 2 married couples. So we've got 4 groups of married couples, and we're choosing 2 groups of married couples from that 4 groups. So we're basically just going 4C2 as our solution, which is equal to 6 different ways, which is very straightforward if you're thinking of it the right way. That was how we looked at it in the question-aided task part. So that one wasn't done as bad as the next one, but you would have had to have shown me the 4C2 equals 6 ways to get your 1 mark for that. Now, part B, or beta in this case. In how many ways can 4 people be chosen if exactly 1 married couple is among the 4 people chosen? And the key word here is exactly 1 married couple. So we cannot have any more than 1 married couple in that choosing group. So in these questions, we're looking at the restrictions first. And the restriction that we're given is that exactly 1 married couple is to be in that group of 4 people. So if we're picking 1 married couple, then there's 4 ways that we can do that, because there's 4 different groups of married couples. Now, we need to choose 2 more people in that group, because the question told us that we were looking for, out of those 4 married couples, we're choosing 4 people. So this is how we choose exactly 1 married couple. How we choose the other 2 people is there's 1, 2, 3, 4, 5, 6 people to choose from. But what we can't have out of those choices of 6 people is this 2 being together, or this 2, or this 2. So there are 3 ways in which we can't have that happen, because these are married, and these pair are married, and these pair are married. So this is the working out that we need for that question, which is equal to 48 ways. And you needed to pop that working out in there to get your 40, and get 48 to get your 2 marks. If you made 1 mistake along the way, you would have lost a mark, and any more mistakes would have lost it all together. Okay, part 2. Hence or otherwise, find the probability that no married couples are amongst the 4 people chosen. This question had hence. Whenever you see hence, it means you're going to use information from the questions before. And the fact that we're using hence means we're going to use the first 2 parts, and it says that no married couples are selected. So if no married couples are selected, if we have a look at what we used before, part 1 alpha, we looked at 2 married couples, and part beta looked at 1 married couple. So if we were to get our total amount of unrestricted ways and take away our answers for those 2, then we're taking away 1 or 2 married couples, which is basically going to leave us no married couples. And that's what we want to do in that question. So if we were looking at unrestricted ways to pick people, and we're looking at, instead of married couples, we're looking at 8 people. So instead of 4 lots of 2, we're looking at 8 people all up, and we're going to choose 4 from that. What we're going to end up with is 70 different unrestricted ways that we could pick people if we were not looking at couples. Now, what we want to look at now is, okay, well, we've got 70 total ways. If we take away the answer we got for part alpha, which was 6 ways, and then we take away 48 ways, that's going to get rid of 2 married couples, and then it's going to get rid of exactly one married couple. And what we're going to end up with is 16 different ways that that can happen. But in order to get your answer correct, you needed to look at the question again, and what it said, and that was another key word in there, was probability. So you needed to find the probability of this happening. So we have 16. I might just pop that as probability. So the probability of no married couples. We're going to get our 16, and we're going to pop that over the total number of unrestricted ways, which is 70, which is equal to 8 over 35. And that was worth only 1 mark for that. You needed to show you're working out to get that 1 mark as well, not just give me the answer of 8 over 35, which I think a couple of people may have memorized from the question 8 task, but I needed to see some working out in there for you to get that mark.